Hello class, today we're going to talk about section 10.3, which is operations with radical expressions. By the end of the lesson, you'll be able to add, subtract, multiply radical expressions. Addition and subtractions. You're going to treat the radical symbol like a variable. So for example, back in the early chapters of algebra, we had 4x plus 2x. That gave us 6x's. There was a total of 6 of them together. Same thing works with square roots. If I have 4 square roots of 5 and 2 square roots of 5, I have a total of 6 square roots of 5. So I just add them together. If it was subtraction, so if I had 4x minus 2x, that would have given me a total or a difference of 2x's. Same thing applies with square roots. 4 square roots of 5 minus 2 square roots of 5 is going to give us 2 square roots of 5. So we just treat that square root like a variable. So for example, if I have 10 square roots of 7 plus 5 square roots of 11 minus 4 square roots of 7 minus 6 square roots of 11, I'm going to look at my square roots of 11 first. I had 10 of them. I'm taking away 4. That gives me 6 square roots of 7. 5 square roots of 11 minus 6 square roots of 11 is negative 1 square root of 11. I cannot put these together, just like I can't put 6x minus 1y together. I can't put 6 square roots of 7 minus 1 square root of 11 together. So that would be my final answer. Go ahead and try this one on your own. 5 and 7 is 12. Minus 6 gives us 6 square roots of 2. Next thing we're going to look at is simplifying when we have addition and subtraction. So you're going to want to try and find a common factor. So 18, 32, and 72. We're going to look for a common factor. We're going to start by simplifying those. So 18 can go to the square root of 9 and the square root of 2. Now we want to check, can 32 use either of those? 32 has the square root of 2 in it, so I can take the square root of 16 and the square root of 2. Then we're going to go ahead and look at the last piece. 72 can be broken down into the square root of 36 and the square root of 2. So what that gives me for this first part is 2 times 3, which is the square root of 9, times the square root of 2, because I can't solve that. Then I've got plus 2. Square root of 16 is 4, so 2 times 4. Square root of 2 stays put. And then I've got plus that square root of 36, which is 6 square roots of 2. Simplifying, that's going to give me 6 square roots of 2 plus 8 square roots of 2 plus 6 square roots of 2. 6 plus 8 is 14 plus another 6 is 20 square roots of 2 for my final answer. So we got 20 square roots of 2. Go ahead and try this one on your own. In this case, your common factor was 5, breaking down each of them so they have a square root of 5 left over. You end up with 9 square roots of 5 plus 2 square roots of 5 minus 7 square roots of 5, giving us 4 square roots of 5. Multiplication, again, works the same way as variables do. So 3x times 5y would have given me 15xy. Same thing will happen down here. 3 times 5 is 15. Square root of x times the square root of y is square root of xy. Notice how the things inside the square roots stay inside the square roots. The things outside of the square roots stay outside of the square roots. That will happen with all of these problems. If it's inside, it stays inside. If it's outside, it stays outside. There is one more thing to note. If I had 3 square root of x times 7 square root of x, that's going to give me 21 square root of x squared. This you can solve. We know that the square root of x squared is x, so I would have 21x. So if you can simplify the square roots, you want to, but you do not pull things out, so I wouldn't just pull this x out of the square root automatically. So I've got 3 square roots of 2 times 2 square roots of 6. Multiplying 2 times 3 gives me 6. Square root of 2 times 6 is 12. I need to look, can I simplify the square root of 12? The answer is yes, because I can divide by the square root of 4. So square root of 4 and square root of 3. So now I have 6 times 2, which is the square root of 4, times the square root of 3. 6 times 2 gives me a final answer of 12 square roots of 3. Go ahead and try this one on your own. Multiply, you get 99 square root of 75, which can be broken down into 25 and 3. 99 times 5 is 495 square roots of 3. Next thing we're going to look at is the distributive property here. So we've got something on the outside and then 2 pieces inside parentheses. The same rules apply. You're going to do 3 times 2, which is going to give me 6. Square root of 5 times square root of 5 is the square root of 25. And then I'm going to distribute again. So plus 3 times 5 is 15. 5 times 3 is 15. Can I simplify these? Yes, I can take the square root of 25, which is 5. So I now have 6 times 5 plus 15. I can't simplify the square root of 15, so that stays put. I can finish up by saying 6 times 5 is 30, plus the square root of 15 is our final answer. Just like I couldn't do 30 plus 10x to get 40x, I cannot combine 30 plus 15 square roots of 15, so this right here is my final answer. Go ahead and try this one on your own. We have 12 square roots of 6 plus 18 square roots of 4. Simplifying the second half to the 2, which is the square root of 4, our final answer is 12 square roots of 6 plus 36. Last thing we need to talk about is conjugates. So this is saying if I have the same square roots being added and subtracted, so a number times the square root of b plus a number times the square root of a is equal to the number times the square root of b minus the number times the square root of d. So if we're looking at this example at the bottom, we've got 2 plus the square root of 7 and 2 minus the square root of 7. This is going to help us solve problems when there are square roots in the bottom, as well as addition and subtraction. The reason we use these, if we go back to chapter 7, when we learned about foiling, we've got first, which is 2 times 2, or 4, plus the outside, which is negative 2 square roots of 7, plus the inside, which is 2 square roots of 7, minus square root of 7 times square root of 7 is square root of 49. Looking at this, the middle pieces cancel each other out. 2 positive square roots of 7, 2 negative square roots of 7. So I'm left with 4 minus the square root of 49, which is 7, or negative 3. So these conjugates enable us to simplify the denominators of a fraction if there's addition or subtraction. So, rationalizing this denominator, I have 3 over 5 plus square root of 7. In order to rationalize it, I'm going to multiply the top and the bottom by the conjugate. So 5 minus the square root of 7. Up top, it then becomes a distributive property. So 3 times 5 is 15. 3 times the square root of 7 is 3 square roots of 7. On the bottom, 5 times 5 is 25. The outside and the inside are going to cancel each other out, so I'm going to skip that, and then minus square root of 49. Now I need to simplify. Square root of 49 gives me 7. So my problem now says 15 minus 3 square roots of 7 over 25 minus 7. 25 minus 7 is 18. So I'm at 15 minus 3 square roots of 7 over 18. Last thing I need to check, I've got 3 numbers, 15, 3, and 8. I need to check if they have a common factor. They indeed do, which means they all can be divided by 3. So I end up with 5 minus 1 square root of 7 over 6. Go ahead and try this one on your own. You end up with 28 plus 7 square roots of 3 over 13. If you have questions about this or any other part of the lesson, please let me know when you get to class.